let's start with our second paper. So the first question in the second paper is, two spherical conductors B and C, equal radii and carrying equal charges in them, repel each other with a force F when kept apart at some distance. Okay. A third spherical conductor having same radius as that of B but uncharged is brought in contact with B, then brought in contact with C, and finally removed away from both. The new force of repulsion between B and C will be what? Okay. So let me be very clear that let's say this is our spherical conductor initially B. Okay, this is our B and this is our spherical conductor C. Question says they both have equal radii. Okay, both are in same size and carrying equal charges. So let's just take an example that this charge on B is Q and charge on C is also Q. Then what is the force between B and C? The force should be, by Coulomb's law, it should be K Q1 Q2 upon separation R square. Okay, let's assume that the separation between both of them is R. Now this is our initial force, so let's call it as F naught. Okay, great. Now it is saying, and this F naught is FO. So the question itself is saying the force is F. So let me make it here F only. Question says a third spherical conductor having same radii as that of B but uncharged. So what is the initial charge on the third one? It is 0. Correct? Okay, uncharged is brought in contact with B and then brought in contact with C and then finally removed. So let's touch it. Let's touch this as let's call it as A, any A, and let's touch it with B. So when you touch it with B, what is the new charge on A? The new charge on A will be equals to Q plus 0 by 2. Why Q plus 0 by 2? Q is the charge on B, 0 is the charge on A. Add both of them and divide it by 2 when you touch them. So it will give you Q by 2. And what is the new charge on C? Oh, sorry, B. This is also Q by 2. Okay. So charge on A and charge on B, both is Q by 2. Now if you touch this A to C, what will be the new charge on C and A? So let's see the second time when you touch, let's call it as A double dash. Okay, let's call this as A dash and B dash after the first touch. The second touch, A double dash, will be equal to how much? The charge on C plus the new charge on A, which is now already Q by 2. So Q by 2 whole divided by 2. So this will become Q by 2, this will become how much? 3Q by 4. When you will simplify, you will get 3Q by 4 and final charge on C will be C double dash, which is equal to how much? 3Q by 4. Great. Let's read the last part of the question once again. The question says the new force of repulsion between B and C we have to find. So let's ignore this A. Let's focus on the final charge on C. The final charge on C is 3Q by 4. The final charge on B is Q by 2. Let's put it back, okay, in our Coulomb's law. So the new force will be, let's call it as F dash, and that will be equals to K, the charge on, new charge on B, Q by 2, the new charge on C, that is 3Q by 4, whole divided by same separation, as they have not mentioned if we have to change the new distance, the separation will still remain same. So this will give you 3 by 8, okay, when you will multiply 3 by 8 K Q1 Q2, which is KQ square by R square. Okay. So initial force will be F equals to K Q1, which is Q, and Q2, which is also Q, upon R square. So if initial force is this, the new force, which is F dash, we get equal to 3 by 8 of the initial force, which is our F. Okay. So the correct answer is 3 by 8. Okay. So 3 by 8 will be our new answer. So option D should be the correct, which is none. Okay. So none means 3 by 8 it should be. Okay. Let's move to our next question. I hope you understood. So our question number 2 on the screen is this one. The question says 3 charges are there, minus Q1, okay, we can locate it, it's here, okay, minus Q1, plus Q2, which is over here as you can see, and Q3, minus Q3, which is over here. Okay, great, as shown in the figure. Now it is saying the x component of the force on minus Q1 is, it's not ID, it is proportional to. So we have to find the x component of the force, okay, acting on minus q1. Let's see what are the forces x, okay, acting on this minus q1. First of all, the force acting on minus q1 due to this q2 will be along the line joining the two in this direction, okay, and let's call it as f1. And what is the next force? That is on q1 due to q3, that will be along this direction. Yes, but wait, we have q2 as positive charge, so the force acting on q1 will be along this direction, and force acting on minus q1 due to minus q3 will be repulsive, will be in this direction. Why repulsive? Because both are negative charges, right? And why f1 is this side? Because this is negative and that is positive. I hope you understood how we made the arrows. Great. So let's find the magnitude first. So f1 will be how much? It should be k q1 into q2 upon separation, which is b square, correct, along x-axis. And what is the force in this direction? Okay, the force in this direction will be how much? If I make this as here, okay, this is angle theta because vertically opposite angle, okay. So f2 cos theta will be in this direction, and in that direction it will be f2 sin theta, right? If you split the components along x-axis, it will be f2 sin theta, and along downward direction it will be f2 cos theta. Great. So what will be the magnitude of f2? f2 will be equals to k, again repeating, negative sign is not considered because we have already considered them in the arrows, right? Because since it is negative or positive charge, repulsion or attraction is because of that, right? So we have already considered them, so we will again write q1 and q3 as it is, upon the separation is a square, okay. So the final answer here will be the sum of both. Which one? We have to find the x component. As per the question, the x component of the force on q1 is proportional to what? If it is proportional, they are saying, so first we will find what is our x component, and then we will take x, this first charge q1 common, okay. So let me just write it here as x component of the force, okay, that will be equals to, what are the x components? Our x components are, let me write it here as f1 plus f2 sin theta, right? Now what is f1? Let's substitute here. It will be k q1 q2 upon b square, and f2 sin theta, that's again positive. Again I am repeating, be very careful with the signs, upon a square and sin theta here also, right? Now if I take now if you look at the four answers in this, okay, all of them they don't have k, so which means they have directly taken it into constant, right? So they are, that's why they are saying proportional to. So let's take k and q1 common, okay, because they will be constant here, okay, common here for this particular expression, plus q3 upon a square sin theta, right? So k q1 we can convert it into proportional, and the final answer will become this part. Which part? Let me put a line here. This part here is our final result. So it will be proportional to that, right? So q2 upon b square plus q3 upon a square sin theta, and that is option B. I hope this is clear. So very simple question. Let's move to our next one, question number 3. Great. Question number 3 says a charged oil drop is suspended in uniform field, uniform electric field. And what's the value of uniform electric field? Let's write it here. What is given? Electric field here is 3 into 10 to the power 4 volts per meter. That's a unit. So that it neither falls nor rises. Okay, just imagine such a situation where something is neither falling and neither going up, which means that is equalized by the gravitational force, right? So here this electrostatic force will be equalized by the gravitational force. Why? Because of this particular statement that it neither rises neither falls. If something is neither falling down nor going up, okay, it is equalized by gravitational force, right? Because gravity is continuously acting on each and everything on the earth, right? And it is pulling everything downward. So here it is, okay. So the charge on the drop, okay, you have to find. The question is find Q. So let me write here Q we have to find. Take the mass of the charge. I think it should be mass of the drop. Should be mass of the drop is m, that is equals to 9.1 into 10 to the power minus 15 kg. So it should be mass, of the drop. Okay, and acceleration due to gravity is 10 meter per second square, because charge is we have to find, right? So mass of the drop is given. Okay, great. So again I am repeating, the situation is, let's say this is a drop, okay, and this is falling down. It is why it is falling down, because sir, gravitational force is acting on it. And what's the gravitational force acting on it? F equals to mg, the weight, right? That's the gravitational force acting on each and everything on the earth, right? So if it is falling down and something is opposing it in the upward direction, what should be that? Electrostatic force. What's the electrostatic force? K q1 q2 by r square, right? Now this happens only if there are two charges. So then, but sir, second charge is not given, then what we will do? Then in that case, there must be something other which is given, right? At that point, which is acting on it to throw this drop in upward direction. And as you can see here, that electric field is applied. Who is applying that field? Some other charge. We don't care about the value of the charge if field is given. So we don't know that, we know that the electric force will be QE, right? So if electric force is QE and gravitational force, let's call it here FG. Gravitational force is mg. Let's equalize both and find the value of Q. So QE will be equals to mg. Why? If two equal and opposite forces are acting, then only the resultant is 0, right? Okay. So here, and then Q, let me put here capital Q, because I have assumed capital Q here. So Q will be equals to mg upon electric field, right? Now what is m? 9 into 10 to the power, sorry, 9.1, they have given 9.1 into 10 to the power minus 15. G, acceleration due to gravity, is 10, and electric field is 3 into 10 to the power 4, right? So 9.1 it is, and no, 9.9, I have copied the part wrong. Okay, so it is 9.9. Let's make it 9.9 as per the question. So here it is 9.9. Okay, so let's cancel out 9.9 divided by 3, 3.3 into 10 to the power. Now minus 15, and this goes up, minus 19 and plus 1, minus 18, and that's the answer. Is there any answer? 3.3 into 10 to the power minus 18? Yes, option A is the correct answer. I hope question 3 is also clear. Let's move to question number 4. Okay. Question 4 says a spherical conductor of radius 10 centimeter. Okay. A spherical conductor is there, and what's the radius of that spherical conductor? 10 centimeter. Okay, great. Now they are saying has a charge of 3.2 into 10 to the power minus 7 coulomb, distributed uniformly. What is the magnitude of electric field at a point 15 centimeter from the center of the sphere? So here, what is the radius here? Radius of the sphere here is 10 centimeter, and that I am converting here only so that we don't have later any confusion. Okay. And the charge here, anything? Yes, charge is given here as 3.2 into 10 to the power minus 7 coulomb, proper unit. We have to find what? Electric field. Okay. Now electric field we have to find at what point? 15 centimeter. So 15 centimeter should be our distance. Let's call it as D. And that is 15 centimeter. So it will be equals to 15 into 10 to the power minus 2. Be very careful. This R is given just to confuse you, right? Okay. We have to find at 15 centimeter what will be the field. So electric field E will be equals to K Q by R square. What's K? 1 by 4 pi epsilon naught, if you know. Q by R square. And what's 1 by 4 pi epsilon naught? Let's put the values. 9 into 10 to the power 9. And charge here is 3.2 into 10 to the power minus 7 whole divided by, what's the separation? Be very careful. You have to find the electric field at 15 centimeter. Then sir, why R is given? The radius of the sphere, just to confuse you. Be very careful with this. So 15 into 10 to the power minus 2 whole square. Now, if the same question is coming from potential, then you have to be very careful with R and the point at which you are finding the field. That we will discuss once we will go in the second chapter. So here, let's simplify it further. So this will be 9 into 3.2 into 10 to the power 2 upon 225 into 10 to the power minus 4. Okay. So let me just calculate it fast, and 9 into 3.2 will be equals to 28.8 and divided by 225 will be 0.128. 0.128 into 10 to the power 6. Now we can simply take it in front, okay, and we can make it as 1.28 into 10 to the power 5. Okay. Yeah, so 1.28 into 10 to the power 5 is the answer, option A for this question. I hope this is clear. Let's move to our question number 5. So question here 5 says, an electron falls from a rest. Okay, so that's the initial information. Rest means, let me just put here a rest here. So rest here, u means 0. What's u? Initial velocity. If something is starting from rest, it simply means the initial velocity of the particle is 0. Rest through a vertical distance h. So height, distance s is equals to h. Okay, in a uniform and vertically upward directed electric field. So it is upward in direction, obviously, because something is falling down, then we have to apply some electrostatic force from downward, right? So upward it is in electric field is E. Okay, great. The direction of electric field is now reversed, keeping its magnitude the same. Okay, now E, this was for the electron. Now proton falls from the rest again through the same height. So distance is again h. Okay, in the same field. Okay, yeah, electric field, they have not changed the magnitude, only the direction is changed because the proton is falling, right? So electric field is still E. Okay, great. The time of fall of the electron in comparison to the time of fall of proton will be how much? You have to check that. It will be greater, smaller, equal, what it will be. Okay, so let's see. It is obvious that it won't be equal. Option D we can directly say. Why? Because the mass is different. Na? If you imagine, like if a heavy object is falling down or if a small lighter object is falling, okay, both will have a different time, right? Different time. If all other parameters are same, be very careful. Huh? If other parameters are not same, then obviously you can talk about equal to, and you can make a situation like that. Okay, so let me come back to this. So if let's take the situation, if an electron is falling or if any particle is falling, any random particle is falling, we will consider electron or proton at the end. So let's say if a particle is falling from a certain height h in the presence of electric field E, then how to calculate the time period? So first of all, that particle which is freely falling means initial velocity is 0, and then it is experiencing some force. Something is falling down, it is experiencing a force, and what will be the force? F equals to QE, charge times electric field. And what is the force? Force will be mass times acceleration from class 11th, right? Laws of motion. So mass times acceleration here. And acceleration will be equals to what? QE by m. So if something is falling down, anything, not only electron, proton, if a person is also falling, and charged person, be very careful in presence of electric field, then acceleration will be this. It's not like if it is not charged, then the situations will be different. Okay, so A is equals to QE by m, and if A is QE by m, let's put it in an equation. Let's see what is the distance it travels in that particular with that acceleration. So S will be equals to ut plus half at square. Again, 11th and 9th standard, you are familiar with this. These are equations of motion. S equal to ut plus half at square. Sir, why only this? Why not other? Okay, in other v square minus u square, you don't have time. Okay, let me write it here, that why we have not used this equation, because here we don't have time, so we will not talk about time. We need time for this particular problem. Answer, why not first one? Because here we don't have distance, but in this particular question we are given with the distance sh h. So h will be equals to u is 0, half a t square. Let's take this a on the left hand side, so 2h upon a will be equals to t square. And from equation 1, let's substitute here A. So it will be 2h m upon QE. Okay, that will be equal to t square, right? And this implies that t will be equal to root under 2h m by QE. Okay, great. Now here, let's consider now, let's look at this formula and consider now electron and proton. Now if a proton is falling and an electron is falling, what is happening in that situation? We know that both of them have same charge, magnitude wise. Obviously polarity is different, but magnitude wise they both are equal, 1.6 into 10 raised to minus 90, right? And if you talk about mass, whose mass is greater? Proton, right? Proton is 10,000 times heavier than electron. So if it is heavier, then time will be more for the proton. So question is asking the time of fall of the electron in comparison to the time of fall for the proton. Looking at this expression without putting the values, we can say since the mass of the electron is smaller, the time will be smaller. So correct answer should be C. Why? Because it can't be greater. Let it be 5 times, 10 times, 1000 times, it can't be, and it is neither equal. Why? Because of the mass present in the final expression. I hope you are clear with fifth one. Let's move to the sixth one in this worksheet. Great. Question number 6 says, two identical metal balls with charge. Okay, let's make a diagram, rough diagram. Okay, so this is a metal ball, charge 2q, another one with charge minus q, separated by some distance. So if they are saying some, let's assume it r. You can assume anything. Okay, I am taking r, and exert force F on each other. So the force acting on them is, let's make it proper, K. What's the charge on the first one? 2q. What's the charge on the second one? Minus q. I am ignoring the negative sign. Why? Because we always take the magnitude in the Coulomb's law upon r square. Great. Now they are joined by a conducting wire. Okay, initially, which is then removed. Okay. So now initially they are not joined. Okay, so this, let me make a rough diagram for separation. So let's call it as this here. Okay, this is the distance, so that you don't get confused. Okay, let's read the question once again so that we will be clear with this particular problem. Two identical metallic balls, identical means there must be same radii, with one having charge plus 2q, another one having charge minus q, are separated by some distance, or let's assume it as r, and they exert force F on each other. Okay, now this is the situation. This is the value of F. How much it is? 2k q square by r square. This is F. Okay, let's read the second part very carefully. They are saying they are joined by a conducting wire. So let me join this with a conducting wire. So basically what happens when they are joined with a conducting wire? Okay, the charge will redistribute it by law of conservation of charge, right? And what will be, let's call it as A, let's call it as B. What will be the new charge on A? So new charge on A will be charge on A plus, but sir negative, yeah, charge you have to take the sign. Sir, why? Because it's a scalar quantity. When you are adding charges, you will take the sign. So this will be 2q minus q, which is q by 2. And the charge will redistribute in such a way that the final charge on both of them will be same, right? So what will be the new force? So the new force will be F dash, which is equals to K, the new charge on A, new charge on B, whole divided by, they are talking anything about the separation? No. So you will keep the separation same. If it is not mentioned in the particular question about the distance, you will not do any change. So this will be 1 by 4 K q square by r square. Great. Now kq square by r square, okay, let's divide this since we don't know. So let's divide this equation 1 and let's divide this equation 2. If you divide both of them, f upon f dash will be equals to 2kq square by r square whole divided by 1 by 4 kq square by r square. Let's cancel out both and 4 will go up and this will become 8. Kq square by r square will cancel out for both. And if you cross multiply, then f by 8 will be equals to f dash. And this is the proof that the new force, f dash is our new force, that is 1/8 of the previous force. So the correct answer for the sixth question is option D. I hope this is clear. Okay, this was sixth question. Let's move to our question number 7. Okay, question number 7 says 2 point charges 3 meter apart and their combined charge is 8 microcoulomb. So let's say there are two charges, one is placed at A, one is placed at B, and let's call it as Q1 and let's call it as Q2, and they are placed at what distance? 3 meter apart. And what is their combined charge as per the question? Sir, Q1 plus Q2 are given as 8 microcoulomb, 10 to the power minus 6 coulomb. The force of repulsion between them, so force between them is given as 0.012 Newton. you have to find the charge. Now, a direct trick can be, okay, a situation can be that, sir, why can't you add all these charges which are given in the option and check if they are 8? We can get directly answer, yeah. But if you see, surprisingly, 4 plus 4 is 8 here, 6 plus 2 is 8 here, 5 plus 3 is 8, so that won't work. You have to actually solve the problem, right? Because the sum of all of them are 8 only. Let's see now. So, if Q1 is this, and then let me make Q2 as 8 into 10 to the power minus 6 in minus Q1, okay. Now, since the sum is microcoulombs, okay, be careful, Q1 and Q2 will be also in microcoulomb. Now, what's a common mistake students do? They make this equation. This is not the correct equation. You will get confused once you will start putting it in the force. How? You will see later. You can try that yourself by taking Q2 as this. So, then what's the problem in this equation? The problem here is, since both of them are in microcoulomb, the sum is there. The left hand side micro part will cancel out with the right hand side part. Let's substitute here. So, force is equals to K Q1 Q2 upon R square. So, force here is given 0.012, K here is 9 into 10 to the power 9. Now, be very careful, Q1 individually is in microcoulomb, so Q1 into 10 to the power minus 6 into Q2, that will be 8 minus Q1 whole into 10 to the power minus 6. Q2 is in microcoulombs, okay. So, be very careful with that. R is how much? The separation is 3 meter, which is 9. Great. Let's simplify it further. So, 9 cancels out with this 9. And this will become 0.012 equals to 10 to the power 9 minus 6, or 9 minus directly minus 12, 10 to the power minus 3, Q1 into 8 minus Q. Correct? Now, let's take 10 to the power that side, it will become 12, which is equals to Q1 into 8 minus Q1. Correct? Now, think about it. Again, I am saying, think about it. Why I removed that microcoulomb which was sitting here. Okay. You can assume some value of Q1 and Q2 and check it. You will get that answer. Okay. So, here, now, sir, how to solve this? This you can multiply and get it in form of quadratic equation. But I can do a simpler method. Simpler method can be putting the options. So, what is our first option? 4. If I put it here, 4 into 8 minus 4. So, that will give us 16, right? That's not correct. If I put the second option, that will save time, okay? Instead of solving quadratic equation, it will save time. So, it is 6 into 8 minus 6, which is 2. Yeah, so second one is correct. Option B is correct. So, that is 6 microcoulomb and 2 microcoulomb. I hope this is clear. Very important problem, many times repeated in exams, okay? So, let's move to question number 8. So, question number 8 says, two identical spheres carrying charges minus 9 and 5 microcoulomb are kept in contact and then separated from each other. Point out which one is true. Okay, great. So, first of all, they are talking about electrons. So, what we have to do? This is initial charge on the first one is minus 9 microcoulombs. And the second one is 5 microcoulomb. Very simple. What you have to do here? They are kept in contact. So, what will be the final charge? The final charge on each one of them are minus 9 plus 5. That will be minus 4 into 10 to the power minus 6 coulomb. Right? When you touch both of them, the charges will add and divide it by 2. So, this will be minus 2 into 10 to the power minus 6. Okay, point out the true statement from the following. Each sphere will have a lack of this much electrons, this much electron, this much electron. You have to figure it out. Then, sir, how to figure out the number of electrons? Recall the first formula of class 12, that is Q equal to NE. We have to count the number of electrons. But, sir, wait. This formula will give us the number of electrons. How do we know if it is excess or deficit? To check that, look at the sign. If something is negatively charged, it has more electrons. If something is positively charged, it is lack of electrons, right? That's the first lecture in class 12. So, if it has a negative charge here, it should be excess. So, our option can be either B or C. So, here what we will do? We will find number of electrons. and check if B is correct or C is correct. So Q here will be minus 2 into 10 to the power minus 6 whole divided by E 1.6 into 10 raised to minus 19. Let's take 19 on the top, okay, and even remove this decimal. It will become minus 20 upon, or let me remove the negative sign, okay, because numbers are there. Numbers are, okay, then no sense of negative numbers here. So 20 upon 16 into 10 to the power 19 goes up, it will become how much? 13, right? And it will be, let's cancel out 4 4s are 4 5s are, so 4 1s are 4 and 0.25 into 10 to the power 13. That's option B. So correct answer here. Very simple question it was, okay. So that is the number of electrons, no units here, okay. This was question number 8 in the second paper. Let's move to question number 9, okay. So question number 9 here, again a beautiful problem. Let's see how to solve question number 9. So question number 9 says a particle of mass m and carrying a charge of minus q1 is moving around a charge q2. Great. The second it is moving around in a circular path of radius r. The time period of revolution of charge minus q1 about q2 will be how much? So you have a charge and that is revolving around the other charge, right? You have to find the time period. To calculate the time period, first of all we will find the force. If it is revolving, okay, if two charges are revolving, one revolving around the other, it's somewhat like, it's like an atom, okay, where you have a nuclei and you have an electron which is revolving around the nuclei. So we will make use of similar kind of concept. So here let's say the charge q2 is placed over here, plus q2, and you have a minus q1. Now this is obvious that at each and every point, okay, and this minus q1 is getting a force inward, right, because they are attractive in nature, right, and there is something which is trying to throw it outward, right, and that both are equalized, that's why they are moving in a circular path, right. So force of attraction between the two charges must be equal to the centrifugal force, right. So what's our force of attraction? Force of attraction will be Coulomb's force and outward will be centrifugal force. So electric force is nothing but K q1, let me remind you once again, no negative sign, upon r square. What is r? The radius of the circular path as per the given in the question, right? And what's a centrifugal force? If you remember from 11th standard, sir, why centrifugal? Because it's moving in circular path, okay. Centripetal and centrifugal force acts only in the circular motion, right? So it will be mass of the particle which is revolving, here it is mass of electron, okay, and v, velocity, mass of the particle is m. Oh, not the charge, it's not saying about electron, sorry. So mass here is m, velocity with which it is moving, so if it is taken as v square upon r. Wait sir, but v is not given in the question. Yeah, that's our unknown quantity, right? But wait, the question is saying the time period, so we will make use of this v to figure out our time period, okay. Let's call it as equation 1. Great. So from here we can find our v square, okay. We will eliminate this v later. So v square will be equals to k q1 q2 r cancels and one of the m will be going down, so m into r. This will be a v square, right? Now if this is your v square, okay, then what will be your v? V will be equals to root under k q1 q2 upon mr. Great. Okay, so this is your v. So v is what? This is our equation 2. Now from 11th standard, okay, we know that v is equals to omega r. Very important equation. Sir, what is this? This is the relation between linear velocity and angular velocity, okay, and this linear will be equals to omega is 2 pi by t, if you remember from 11th standard. So cross multiplying time period will be 2 pi r upon v, correct? But we have to substitute here v on in equation 2, so we will not put this, we will substitute here because we have to find it in terms of that. So let's put it there. So here this is equation 3, from 2 and 3, 2 pi r upon t, okay. In case if you don't remember this relation also, and if you are finding it little confusing, you can directly see if something is moving in a circular motion, its circumference will be 2 pi r, and whole divided by the time period, that will give you the linear velocity, right? This speed equal to distance upon time. You can think it like that. But this will be frequently used in other chapters as well. So do remember this 2 pi r by t, and that will be equals to root under k q1 q2 upon mr, correct? Let's cross multiply. So t will go on the top and it will become 2 pi r into root under, this will become how much? M r upon k q1 q2, that is equals to, correct? So we got our time period like this. Let's see if there is any option like this, 2 pi r into that thing. Oh great, we don't have. Okay, so what we got, let me put it on the top so that we can compare there. Okay, so we got our time period here as 2 pi r root under, okay, root under how much? mr upon k q1 q2. Okay, let's see what's the problem. Okay, great. So they have not used one thing. We can see, let's see the difference in all the options. We can see here they have not used k anywhere, which means I have to convert this k into 1 by 4 pi epsilon naught. That will eliminate these 2 pi. And what about r? We can take this r inside the root. So let me make some changes in our outcome so that it might look at like the 4 options. Okay, so t is equals to, let's take 2 pi and let's take r inside. If you take this r inside the root, what will you get? You will get r square. Inside the root, if you take it, you will get obviously r square. So that r square and this r will become mr cube. And k, I am putting 1 upon, so 1 here, and upon it will go on the top 4 pi epsilon naught upon q1 q2, correct? I hope this is clear. Okay, and further if you want, you can take pi square also inside. Okay, so let's take pi square inside because they have nothing outside, okay, in the root. So either the option is A or option is C because they are only coming in root and they have nothing outside. So let's take 2 pi also inside. So what will happen if you take 2 pi inside? It will become 4 pi square. Yeah, square it when you take it inside and root it when you take it outside, right? So 4 into 4, it will become 16 pi square and pi cube epsilon naught mr cube upon q1 q2. This is our time period, right? So let's see, is there any option? Yeah, option number A. So option A is 16 pi cube epsilon naught mr cube upon q1 q2. Okay, so this is our correct answer for question number 9. Let's move to the last question for this worksheet. Our last question for this worksheet is 2 point charges, q1 is this and q2 is this, are located at the position this. Okay, we are given with positions respectively. Find the force on F12. So we have to find the force F12. Force F12 is, let's see, let me first write the expression and then we will start solving this. So F12 here, okay, that will be given here as F12, and F12 we have to find, or F21? Okay, F12 we have to find. So F12 will be given here as 1 by 4 pi epsilon naught, okay, 1 by 4 pi epsilon naught q1 q2 upon r12, okay, or you can, as they have given in the textbook, we can make it as r21, correct, whole square into r21 unit vector. Okay, so here we will make use of few concepts of vectors from class 11th. This is our force expression. So first of all, let's find what is our r1. Let me reconvert this coordinate form into a vector. If you remember from 11th standard, so r1, the position of the first one is 1 I cap plus 3 j cap and plus 2 k cap, right? They have written in coordinate form, I have written in vector form. r2 vector will be, you have to put arrows also, be very careful, but in competitive exam they don't care, you just need to write the final. Okay, so 5j and 1k, right? So this is r1, okay, and r2. So r1 and r2 is done. So r21, okay, r21 will be r21, okay, vector will be equals to how much? r1 minus r2. Okay, R12 is R2 minus R1. You must have learned that in 11th standard, and R21 will be R1 minus R2. So R1 minus R2, when you will do 1 minus 3 is how much? Minus 2I cap, 3 minus 5 minus 2j cap, and 2 minus 1 which is k cap. I hope this is clear. Okay, so this is our vector R21. Next is, if this is R21, okay, next is we have to find the magnitude of this R21, because we have, the unit vector. For that we will require magnitude. So magnitude will be R21, which is equal to root under minus 2 square, which is 4, minus 2 square, which is 4, and 1 square, which is 1. So that will be equals to 4 and 9, which is 3. Okay, this is our magnitude. Okay, how do we find the unit vector? So sir, unit vector from class 11th is R21 cap will be equals to R21 vector upon magnitude of that vector, right? Okay, so let's put here. So this will be, what is our R21 vector? Minus 2I minus 2j plus k cap whole divided by 3. Okay, we got our data. So let's substitute this value in our this problem, so that we can get our, okay, F12. So 1 by 4 pi epsilon naught, it will be equals to 9 into 10 to the power 9. What is our first charge? As per the question, Q1 is 5 into 10 to the power minus 6. Q2 is 3 into 10 to the power minus 6 whole divided by R21. R21 is 3. Okay, be careful here, you have to place the magnitude of this. Okay, so 3 whole square, and R12, let me write, since there is little space, let me just keep it here in vector, because anyways that will be in vector. Okay, I hope this is clear. Great. So we will substitute this at the end. So let me first simplify this. So this will be 3 square is 9, and 9 cancels. 5 3s are 15 into 10 to the power minus 3, because minus 12 and 9 minus 3 R21. Now let's substitute here R21 what we got from here on the right hand side of the screen. So here let's substitute it. This will become minus 2I minus 2j and plus k cap whole divided by 3. Let's cancel this 3 with 5, 15, 5 into 10 to the power minus 3 into minus 2I minus 2j and plus k cap. Let's see if any of the above answers which are given is correct. Okay, so they have given minus 5. So let's multiply the whole equation with minus. So this will become minus 5 into 10 to the power minus 3 whole, and that will be newtons. Okay, so 2I plus 2j and minus k. 2I plus 2j minus k. 2I plus 2j minus k. Option A is correct. Okay, so this was our question number